Hello, my name is Munkaila Musa. I'm presenting from Michigan Technological University, USA. My topic is on the laboratory testing on the phase-bond durability of cross-laminated hardwoods. Cross-laminated timber is a prefabricated engineered wood product made of at least three orthogonal layers of graded sawn lumber or structural composite lumber that are laminated by gluing with structural adhesives. Simply put, as gluing wood layers together sequentially as perpendicular layers to redistribute the strength as wood strength follows the fiber direction. What fascinates me as a wood science engineer and a forester is how wood makes amazingly beautiful spaces that feels very good to be in and very robust and very solid. CLT has architectural freedom, is fast, cleaner, and better for the environment. But to achieve this, we need to ensure proper usage of this CLT and its durability based on the type of adhesive that are used. And we can say that the adhesive has been a key factor in the efficient utilization of timber resources in many different applications. Several factors of the wood and that of the adhesives, including the way in which it penetrates into the wood and the stress concentration, dictates the bond performance. The goal of this particular study is to determine the suitability of an adhesive for use under various levels of severity and conditions with specific and appropriate test method. 320 delamination blocks were made of about 2" by 3" blocks, and we have 8 replicates for the 2 adhesives, specifically melamine and resorcinol. So in total, we have 640 delamination. And according to the AITC test 110-2007, what we did was these particular blocks are immersed in sufficient water of about 65 to 85 degrees Celsius. A vacuum of 20 to 25 is withdrawn when it's put in a cylinder and held for about 30 minutes. A pressure of 75 is then applied, which is considered as the wetting stages. Then it is now put in an oven and air dried within 10 to 15 hours to get about 15 percentage weight change. And this is also considered as the drying method. We also subjected the bond line into analysis using scanning electron microscope. So the scanning electron microscope images was taken from a 10 by 10 millimeter square cut from the center of each cross lamination with the bond line placed at the center at 39 millimeter working distance. The accelerating voltage was 15 kilovolt under 3 different magnification, which is 300, 200, and 100 magnification using the Joule 6400 SCM with tungsten source scanning electron microscope. And what happens is we determine how much the adhesive seep into the wood cell lumen. So adhesives that are fully filled are considered the rate in which it penetrates. And so we trace using image analysis tool like ImageJ to determine how much it seeps into the wood to determine the maximum adhesive penetration. So from the results, from the delamination test according to the AITC, we realized that basswood and white red pine did not show any delamination, though there was some delamination in yellow birch, white ash, and also some part of white pine with specific with resorcinol. Then what we did was we used the mosaic plot from logistic regression to identify the rate in which this species delaminate, and we realized that from the graph, from the painted the graph painted black, we can say that several species like yellow birch, white pine, and white ash and aspen had a record of delamination rate above 50%. Then in terms of the mixed species, you consider from the results that we got, almost all the mixed species have a delamination below the 8% requirement by the AITC test, and though hardwood cross lamination tend to have a higher delamination. And this is an image showing how the cells were put into the ImageJ for analysis, and this was done according to their pore distribution. So from here, we can see from the results that species like abrupt diffuse porous, gradual abrupt, and gradual diffuse porous and gradual ring porous tend to have relatively higher penetration compared to the other sort of type of combinations. And when we try to see if there was, from the linear regression, if there was any relationship between the adhesive maximum penetration and the delamination percentage, we realized that from the melamine, there was relatively strong association between the delamination percentage and adhesive maximum penetration, although we did not get same for resorcinol. Sort of type of combinations. And when we try to see if there was, from the linear regression, if there was any relationship between the adhesive maximum penetration and the delamination percentage, we realized that from the melamine, there was relatively strong association between the delamination percentage and adhesive maximum penetration, although we did not get same for resorcinol.